Alright, lecture 17 today. We're going to talk about proportional figures and do a couple more things with angles formed by intersecting lines. So let's begin. This is kind of going to be a review, more or less, from yesterday's lesson. What we got here is we got two triangles that are supposedly similar. We got to determine if they are similar or not, really. Okay? Are these similar figures? That's going to be the question. Are they proportional? Okay? So I'm going to put proportional underneath. Okay? Because if you remember, the sides of similar figures have to be proportional. Alright? Now, what I'm going to do is, they may not even give you these angle arcs. So I'm just going to concentrate on the numbers here. Let's write our ratio and proportion. Okay, I'm going to write 12 over 10. And then equals 8 over 7. Now, I know there's no variable involved. That's not the big deal. The big deal is, for something to be proportional, if I just cross multiply these numbers after I set up a ratio of proportion, if they are equal to each other, that says that they are similar figures, that they are proportional. Okay? So what I'm going to do is I'm going to cross multiply both these numbers here. So let's go back to just 12 times 7. 12 times 7 is 84. Well, if I do 10 times 8, that gives me 80. That is not a true statement. 84 doesn't equal 80. What that means is that these two similar figures are not proportional, okay? Which in turn means that they are not similar, okay? Now, if we ended up with something here that equaled each other, then they would be proportional. They are the same. Well, not same size, but they are similar. Okay? So there's one example there. I want to do something real quick with proportional, setting up ratio and proportions, similar figures. Okay? Something that might help you guys out. I probably did this with one class, but nonetheless, this is what I want to do. Let's say I want to find the value of x, and I have 12 here. I'm just making up numbers here. Let's put 6 and 7 right here. Okay? I got a couple rules that you could use, because let's face it, if you can set up proportion, you should be able to solve these. Alright? What I'm going to do is I'm going to teach you a quick little method here. There's not just one way of setting a ratio and proportion up. Okay? There's could be up to 8. Alright? What I like to do is I like to find what side I'm looking for. And I can put it really anywhere I want in this ratio and proportion. So I don't know if you can see the mouse here, but you can put X at the top left, top right, bottom left, wherever you want. I'm going to get a little crazy here and put it at the bottom left. Now here are the rules, okay, when you're setting up a proportion. You can't, there's two can'ts. The first can't is can't cross multiply sides from the same shape. Okay? So if I want to figure out what I can put here and cross multiply, well, one thing's for sure, you can't cross multiply sides from the same shape. Well, what number am I referring to? What number is in the same shape as x? 12. I better not put 12 there. I can put 12 anywhere else. Okay? Now, rule number 2. I want to put it down here. Rule number 2 says this. Can't cross multiply, I'm abbreviating here, corresponding sides. Okay? So if I think about corresponding sides, well, of x, we're looking at x here. So if I'm looking at x, what's the corresponding side of x in the second triangle here? 7. I can't put 7 in the top right. I'm going to put it somewhere else. Well, what can I cross multiply with x? 6. Okay, so I'm going to put 6 right there, if my computer will let me. Sometimes it won't, sometimes it will. Okay, there we go. Now I can cross multiply and divide. So you got 7 times 12 is 84. And if I have to punch it in on the calculator, I get 84 divided by 6. And that equals 14. So 84 divided by 6 equals 14. Alright? Guys, know these 2 rules because you're going to be using them tomorrow in tomorrow's lesson, daily math practice. Alright, let's go on example 2 real quick. Getting ready to run short on time. What they want us to do, we need more practice in this, is apply theorems, alternate exterior, alternate interior, vertical angles, all those theorems that we've learned in the past, and we're going to have to find 3 different variables here, x, y, z. Now, here's the thing, alright? Find the one that you think is going to be easiest for you first, okay? Right now, I'm looking at, I'm going to change colors of my ink pen here, okay? 106 and the 2y. I'm going to focus on that little area right there. Okay? Now, what I need to do is I need to set up equations. Alright? Now, notice that these 2 angles down here, 106 and 2y, are supplementary. So what I want to do is I want to set up an equation. Okay? Set them equal to 180. Guys, it's going to be key that you do this. Now, since these 2 angles are supplementary, they equal 180, I'm going to take 2y plus 106. Now, I can easily subtract both sides. Okay? And that gives me 74. Bring down 2y. Okay, now we're in the solving equations again. I'm not going to go into detail with that stuff. Y equals 37. So I just found y. Now, that's not the angle measure, guys. That's just y, the variable. We got to be able to figure out just the variables. Alright? Now, with that said, I could easily figure out x if I use what? Well, let's think about this. If I use the vertical angle theorem, I may have to use y, come to think of it. Okay, plug in 37 in for y. You got 2 times 37, which is 74. Okay, so this angle measure is 74 degrees. What I'm going to do is I'm going to use vertical angles and label this as 74 degrees. Now, inside the parallel lines, if I cross the transversal and stay interior inside, guess what? X, okay, is also going to be 74 degrees. Now, the thing about it is, X is just X. So, we already found X. X equals 74 degrees. Alright, now, last but not least, Okay? We got to figure out Z. Z might take a little bit of planning. What I'm going to do is I'm going to use, well, I mean, there's more than one way. I can use alternate interior, okay, cross the transversal here, stay inside the parallel lines here, and then I can cross the transversal again and see that 4z plus 6 equals 106. So I need to set up that equation. 4z plus 6 equals 106. Now subtract 6 to both sides. Now I can solve. 4z equals 100. Divide both sides by 4. And we end up with 25. Alright guys, so there's Z. I will see you tomorrow.